Well, now we come to what usually is more fun part of spreadsheets, and that's learning how to build an interactive spreadsheet or a simulation. Um, right now, I'm actually gonna look at the behavior of a cubic equation by building a spreadsheet simulation. Okay, we're going to take the standard form of the cubic equation and we're going to build it so we can get a graph to essentially when the A, B, C, and D coefficients are changed, how does the shape of the curve or the position of the curve influence by changing one of those variables at a time. So now, once you learn how to do the cubic, you can build yourself a whole series of your favorite mathematical equations: linear, quadratic, exponential, logistic, and examine behavior. Great way to learn some mathematics. If you're in science, if you've got an equation with a number of variables in it, you can turn it into an interactive simulation. Whether it's biology, you can look at population. If you're a chemist, you can look at Beer's law. You could look at the ideal gas law, a whole bunch of different things. Okay, so how are we going to do this? Well, once again, it's time to get a new spreadsheet. Okay, so you want to get the spreadsheet building a simulation. Okay, download it, make a copy. Okay, and then on the first tab, I've given you a little bit of structure just so we can move right into this. We're going to have X go from plus 10 to, I believe, minus 10. If I sneak down there, yeah, that's already in position. In the Y column, then, we need to feed the cubic equation, which means I have to be able to give each one of these variables. A gets x cubed, B gets x squared, C gets x, and D, it's a constant, okay? So I'm going to be able to feed these in. We also are going to have to introduce, these guys are going to have to go in with an absolute cell reference. You may have saw the partial one in the first video, but we'll review that. So in here, we're going to put the cubic equation, okay? So I need to start my building by putting in that. I need to feed in A, so I'm going to click on that cell. And now this, if I drag this down and leave the E3 as is, it'll change to E4, E5, E6, okay? And just drag down, and I want to keep it on E3. So I'm going to put a $sign in front of the row and the column reference, and now I will have locked that in. I need to multiply that by my X value. This I want to leave as a relative reference because that I want to change, and in the case of A, it goes with X raised to the third power. I now need my second coefficient, B. I need that to be an absolute reference so it doesn't change. I'm going to multiply that by X, but now the X has to be squared, so I need the caret squared plus I need C, and I need to lock that in, times X to the first power, so I don't need to do anything. And now I need to add my constant, but my constant needs to be locked. Okay, so there's there's the standard form cubic equation. Ax cubed plus bx squared plus cx plus d. Okay. When I do this, I get a 0 because I don't have anything in here. So I'm going to put ones in so that there is something in each cell. Okay. This was 10 cubed, 10 squared, 10 and 1. So 1,000, 100, 10 and 1. Okay. Now, here's a good time to use the auto. Okay. If it doesn't give you auto, if you double click, it'll fill it in as well. There it is. Okay. So we fed the cubic equation. If I change something, will you see an effect? Well, let's change this to -2. And I get a response. Okay, so what I want to do now is I want to graph it, because I want to see how I don't want to read a big column of numbers. Okay, so I am going to highlight my data set. Ooh, we're almost there. We're almost there. Okay, I'm going to highlight it to right there. I'm going to very carefully sneak back up, because if I draw the graph now, it'll be at the bottom, and I want it up at the top. Okay, I've got my X and Y highlighted. I'm going to hit the insert chart. It's going to take a little while to work. And, whoa, there it is. Okay. It actually did a scatter chart. Okay, I am going to just move this over a little bit. I am actually going to make it a little bigger. I'm going to go in and do a couple of things, but let's make it a little bigger just so I can have a little bit more to see on there. Okay, now the reason you get a nice continuous curve there is because if you look carefully, it's really just those big blasted data points. Okay, I'm going to go back up here. Let's put this back to 1 and see what happens. Flips. All right. I want to do a few things now. Notice this time, because this was a relatively simple graph, I put the Y on there, put the X on there. Okay. What happens if I change this to 760? Notice how nicely I can see behavior. It shifts the whole curve. In this case, if D is positive, it goes up. What happens if D is negative? Just go in there and slip a negative sign in. It drops below the axis. Okay. Now, what I want to do is go in here, and I'm going to shrink my data points down a little bit, maybe make them squares. Okay, let's try making them a 2 and see what happens. Okay, now you can definitely see the data points. Now I made them really too small. Didn't quite want to make them that tiny. What do they have in there? Let's try 5. Okay, I don't smack anything. All right. The other thing I want to do is, because I can slip up and go to series, and go down here and put a trend line on, I can actually look at this as a nice smooth curve. Let's make this 100%. Okay, I don't want it to be linear. I want it to be a polynomial, and I don't want it to be a second order polynomial or quadratic. I want that to be, and now I don't know what I did, but I whacked the graph off. I want to go back. If I click on my regression line there, which is a parabola, it doesn't fit. I'm going to go here, and let's use the drop down, change that to a 3, and now I'm actually going to go back to the series, and I am actually going to turn my point value off, and on doing that, I now have the smooth regression curve, which fits perfectly on there because how did I generate the data? I generated the data by using the function, okay? Now you can look at behavior. If you turn the B to 50, what happens? Well, now you see a much smaller part of the curve. So it would be nice to have, I could go back and change this, okay? But look how easy it was to feed the variables in. Okay, so all this is, okay, click on that, and it's telling you that we're throwing the x in and the 4 coefficients to see the influence there. Let's set that back to 0. See if we get a. Still can't do it. I guess I just made that too big. So maybe, whoops, I don't want a 5 there. Let's change that to a 5. And see if we can get a little closer. Yeah, now it looks like we shifted. Looks like we're shifting what? Okay. We're getting a little more. It's not as flat, even though it is never flat in there, but it may appear to be flat. So now you have a cubic equation. Could you make this a little fancier? Well, the answer is yes. And if you go up here to View and open the Advanced tab, okay, I added a comparison. Okay, I also added the capability of shutting the comparison on and off, okay, so that if I don't want it, I can do it. I also added a little red dot there. That little red dot is a very fancy place, okay. It is the what? If you know a little math, okay, it is the inflection point in there. Okay, and now you can see a little more when you have a comparison. And I also added the ability to change the scale, to set where you start and what the step size is. So we're going to start at 50 and we're going to step down 1, minus 1, minus 2, minus 3, okay, by putting simply just take away, add the step. But then I made the step negative. You could have put minus 50 and then added plus 1. How to do this is explained down here, how to get the checkbox in. Okay, to do a checkbox, you have to use an if statement. Okay, that gives you, a checkbox gives you an on-off switch. Okay, and again, just explore the formula there. And you now have the ability to change your x-axis. In other words, if your coefficients blow the thing out of the 10 to minus 10 window I had, okay, you can reset the window. Might take some playing to find it, okay? And if you really wanted, my comparison, and it was the way I set it up, is I set all the coefficients on the comparison curve to be 1, 1, 1, and 1. you could also put a comparison curve that you could also change so that if your curve gets too far away from the comparison, you can make your comparison, you can shift that. I didn't do that here. I left that kind of to you so you could play with this some more. If you want to know a little bit more about cubic functions, there it is. Or if you own a math book, you could look it up in there. Okay. But right now here, this is an easy one to do. Okay. Sit back, try it. Pick an equation. Pick population growth, exponential growth. Pick radioactive decay, which is just population growth with a negative e to the x up there as opposed to positive. Pick a logistic equation. Pick a quadratic. Pick linear. Okay, anything you want to do, try it. Okay, and see what happens. Hope you enjoyed. I will probably add some other simple builds, some simulations, just to show you how you can get started. I also, on the web page where all this stuff is posted, if you're interested how to set up the random error or build random error in or build in systematic error to equations, I'm going to put some information on how to do that. All right, happy spreadsheeting, and good luck with anything you try. Don't hesitate to contact me if you have questions. My email is on my homepage, where if you found these videos and the spreadsheets, just click on the home button up top in the upper right hand corner and get out of one of the link pages, and you'll find my email. All right.